Hello, good afternoon students. Today I will start my discussion on conformational analysis of the cyclic six-membered alkane, which we call it as a cyclohexane. So this is the details of the conformations of cyclohexane. Sachet's suggestion. Sachet was a scientist in 1890. He could able to describe the structure of the cyclohexane. That is, the cyclohexane exists in a folded form and all nuclear carbons do not lie in one plane. According to him, all nuclear carbons do not lie in one plane. And here these are the four different conformations which are for cyclohexane. This is chair conformation, this is boat conformation, this is twist or skew boat conformation, and this is half chair conformation. Means according to Sachet, there are four different forms of conformations which are common for cyclohexane: chair conformation, boat conformation, twist conformation or skew boat conformation, half chair conformation. So this is how we can represent for all these conformations. And here if you take one by one, chair conformation, the shape is like a chair. Just you can see this structure of this conformation. It looks like a chair. And here you can see there are 6 carbon. 1, 2, 3, 4, 5, 6. And all these 6 carbons, they are associated with 2 hydrogens. So there are 12 hydrogens which are associated with a carbon. So number of carbon atoms are 6. So all these 6 carbon atoms are sp2 hybridized carbon atom. And the bond angle between the 2 carbon atoms observed is 109.28 minutes. So which is a normal tetrahedral angle of sp3 hybridized carbon. So number of hydrogen atoms are 12. As I said just now, each carbon is bonded with 2 hydrogens. So accordingly, among 12 hydrogens, we can classify them into 2 sets of hydrogen atoms, 6 plus 6. So they are named as axial hydrogen atoms and equatorial hydrogen atoms. And here accordingly, there are 2 types of bonds which are observed in cyclohexane. One bond is named as axial bond, another one is equatorial bond. Accordingly, axial hydrogen, equatorial hydrogens. So we can say the 6 axial positions perpendicular, they are perpendicular to the ring and they are parallel to the ring axis. And the bond positions and the bond in these positions are called as axial bonds, and the atoms or groups are called as axial hydrogens. Means the bonds which are axial, that which are perpendicular to the ring and which are parallel to the ring axis, are called as axial bond. The hydrogen atoms associated with these bonds are called as axial hydrogens. Similarly, the 6 equatorial positions are in rough plane of the ring around the equator, that is projecting outwards from the ring. Bonds in these positions are called as equatorial bonds, and the groups atoms are called as equatorial hydrogen atoms, say if they are hydrogen. And here the positions are rough plane of the ring and they are around the equator. They are projecting outwards towards the ring. So this is the model which we can see, and see, this is the bond axis, this is the ring equator, dotted line, whatever I am pointing, this is the ring equator and this is the bond axis. And here the red ones, the red atoms, red balls, whatever we are observing, they are called as axial hydrogens, and the blue dots, the blue point, they are called as equatorial hydrogens. So if you see the normal structure, if you write on the board, the structure will look like this. So you can see the 6 hydrogens and 6 carbons. This is the 3 carbons are axial carbons, 1, 2, 3, and these are the equatorial carbons. And here just you can see the hydrogens associated with them are the axial hydrogens and equatorial hydrogens. And here if you see here, if you see here, the 6 axial bonds, one on each carbon, are parallel and alternate up and down. So these are the bonds, we call them as axial bonds. They are parallel and they are alternate up and down. These you can see, this you can see, these are up to pointing towards upward, these are towards the downwards. Okay, they are parallel. So this is upward and this is downward. So like this, the axial bonds are represented. Then the hydrogen associated with such bonds are called as axial hydrogens. And if you say in case of equatorial bonds, the 6 equatorial bonds come in 3 sets of 2 parallel planes. So you can see the parallel planes of the molecule. This is one parallel plane and this is the another parallel plane. And the bonds arising around this plane, which we call it as in 2 ring bonds. One is above and one is below. And equatorial bonds on the 2 sides and alternate between the 2 sides around the ring, we are going to call such them as equatorial bonds. And these will come in parallel lines. Just you can see these are perpendicular and these are parallel. Okay, so the hydrogens or the groups which are associated with this line, which such type of bonds are called as equatorial hydrogen atoms, and the bonds are called as equatorial bonds. So these are the 2 equatorial bonds. These are the 2. These 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. These are axial. These are equatorial. Means that these are parallel and they are alternate up and down. Of course, these are parallel between the 2 planes, and each set is parallel to the 2 rings which is covers above and below the plane. So if we see the completed structure, you can see this is the equatorial bond and this is the axial bond. Here also the same thing. This is axial bond and this is equatorial bond, and this is axial bond and this is equatorial bond. This is equatorial bond, this is axial bond. This is equatorial bond, this is axial bond. This is axial bond and this is equatorial bond. So in order to differentiate the equatorial and axial bond, they are shown with a different color. This blue color represents for equatorial bond. The pink color, it represents for axial bond. So this is how we can show the 2 types of bonds in cyclohexane. Another conformation of cyclohexane is boat form. It looks like a boat. So same number of carbon atoms are 6. All carbon atoms are sp2 hybridized, and the bond angle is same, retains tetrahedral angle. The number of hydrogen atoms are 12. But in this case, the 4 types of hydrogen atoms are present in case of boat conformation. That is, first type is flagpole hydrogen atom, they are number 2. Bowsprit hydrogen atom, they are 2. quasi-axial hydrogen bonds 4, quasi-equatorial hydrogen atoms 4. So total will be 12. So this is how they are classified by different name. What are these? Flagpole, what is bowsprit, what is quasi-axial, what is quasi-equatorial? Just we'll see that. So here, this is the ring axis, and we can say the types of hydrogens here, and they are named with all these types. Accordingly, FP means that is flagpole hydrogen. So if hydrogen atom, say here I am pointing, this is a flagpole hydrogen, and if it is written with BS, say for example, this is written with this hydrogen is written with BS, that is a bowsprit. This is flagpole and this is bowsprit. And QA, so where it is written with QA, say for example, this is associate, this hydrogen is associate QA, that is quasi-axial, and one more is QE, this is QE, that is quasi-equatorial. So like this, all 4 hydrogen atoms in 4 types of hydrogen atoms, total 12 hydrogen atoms which are present in the both conformations can be given representation like this. Just you can compare this representation with the axial as well as equatorial. See, the flagpole, they are in number 2. Okay, so this is one flagpole, this is another flagpole, this is one bowsprit hydrogen, this is another bowsprit hydrogen, this is one quasi-equatorial hydrogen, and this is another quasi-equatorial, quasi-axial hydrogen, this is another quasi-equatorial, and this is another quasi-axial hydrogen. So here this is quasi-equatorial and this is quasi-axial, this is quasi-axial and this is quasi-equatorial. So like this, these are the 2, 1 plus 1, 2 flagpole, 1 plus 1, 2 bowsprit, 4 quasi-axial and 4 quasi-equatorial types of hydrogen atoms are present in both conformation. Accordingly, if you want to know what are these, just you can give the definition by taking with respect to ring axis, which are in the plane of the ring, which are out of the plane of the ring, etc., which are parallel to the ring. Like that you can give. So this is how, this is only for the representation. You can represent all the 4 types of hydrogen like this. And the next 2 types of conformations are twist boat and half chair conformation. What is this twist boat? This twist boat is the conformation which is obtained by the twisting of the boat, and this is obtained after the release of steric strain, which is due to the interaction of flagpole hydrogens, flagpole hydrogen interaction. Flagpole hydrogen interaction. So just these are the 2 flagpole hydrogens of, these are the 2, okay, and if they are when the boat is twisted, you can see this twisting releases some strain which is obtained by the side by side of the hydrogen, which we call it as a steric strain. The interaction due to the steric effect of the 2 hydrogen atom releases after the twisting. So this is how, this is one boat conformation. After twisting you will get this. This is a stress release free conformation, which we call it as a twist boat conformation. Half chair conformation is obtained if C1 or C4 of chair conformation is brought in the average plane of the ring. Okay, if C1 or C4 of the chair conformation, okay, and if it is brought in the average plane of the ring, the conformation is known as half chair conformation. So this is how it is obtained. C1 or C4, it is forcibly brought to the plane of the ring, and whatever the conformation is obtained, it is called as half chair conformation.